probably heard your teacher talk last year about these being area. So when we go 3 times 4, we're actually looking at the factors, would be 3 times 4. And those are kind of the dimensions of the rectangle. So we would have a length of 3 times seen by a length of 4. And what we're looking for is the answer, which is the inside. For the inside answer, we just trace our lines. You guys know what 3 times 4 is. What is 3 times 4? 12. And you can see here I have 12 squares. Okay, so 12 is your product. So for your multiplication statement, we would say 3 times 4 equals 12. It's the whole thing. Okay. And these are your factors. And this is your product, the answer to the multiplication. Okay, so you're going to hear those vocab, and that's kind of what we're talking about. Right? So the product is essentially the area. So multiplication using tiles. Please draw 2 times 3. And you can create it too if you want. I don't care. Now again, it doesn't matter, or not again, but it doesn't matter where the 2 or the 3 goes. It'll just change the orientation of your rectangle on the inside. But 2 times 3 equals what? 6. So there's your multiplication statement. 2 times 3 equals 6. So then last year you did these ones as well, whereas 2 times 3x plus 1. So what this is saying is we have 3x plus 1. There's 1, 2, 3 plus 1. And we have 2 groups of those. Okay. So now you can extend your lines. Trace your lines on the inside, going down and going across. So what do you have? 6x plus 2. How could you do that without the algebra tiles? Right. It's kind of like you're having 2 3x plus 1s. Right. So there's 2 of the first part, 2 times the 3x, and a 2 times the plus 1 part. You guys remember that from last year? Okay. Then we started getting into harder ones. 2x times x plus 3. Okay. So I have 2x going down this side, and x plus 3 going over here. Try and keep your x's approximately the same. Okay. I know it's a little bit hard, but okay. Then trace the inside. Cool, we've created a new shape now, haven't we? What's that new shape we've created? X squared. Okay, and that's because of the exponents. So now we have, our answer is 2x squared plus 6x. Okay. So what we did is we multiplied the 2x by the both parts. Now for the multiplication statement, you can see at the bottom, I should just rewrite the whole thing. Don't be lazy. Okay, I want to see everything. Oops. 2x squared plus 6x. Now on your quiz, I photocopied it too early and I forgot to change it to multiplication statement, but that's fine. I'll mark it very leniently. Okay, try 4 all by yourself. Go for it. Now you have a negative sign. You're going to have to be careful. Decide about the negative sign after, okay? So just draw your shapes first and then shade in after. Okay, so what do we have? Oh, forgot to shade. So the shading, negative times positive, means that these shade in. Okay, so we have 6x minus 3x squareds. Okay, so again, if we were doing these without our tiles, it would be 3x times 2. That gives us 6x. We only multiply the numbers. And then 3x times a negative 1 gives us a negative 3. X times x gives us the x squared. Okay. And the reason why is because we're adding the 1 exponents together. Any questions? That's kind of where we left off from last year. Okay, right there. So, without tiles, you want to multiply first, then collect like terms if you can. You're not going to do that for the first one. The first one is just multiply. So I always like to use my arrows. So I multiply 3 times 2x squared. What do I get? 6x squared. Now I did that, so then I use my arrow and do that again. 3 times negative 4x, negative 12x. And the last one, 3 times plus 7. Plus 21. There's your answer. Okay? The arrows help you remember what's happening with your multiplication. For question number 2, 3 times x, 3 times 6. Do that multiplication first. And what's the other multiplication that needs to be done? Yeah, now I always like to remember that as positive 4. Okay, that sign and that number have to stay together. Can't screw up addition, but subtraction you can. So always think about that as being together, and you'll never get a wrong answer. Okay, so those are together. Multiply in. And now you can collect like terms for a final answer. Okay, so how many x's do you have total? And how many 1 tiles? Plus 10. Okay, I wonder how you guys are doing. Thumbs up, down in the middle. Good. Okay. Go ahead, next one. Draw an arrow, multiply in. Collect like terms. Here you have to be super careful with your signs, okay? Negative 16x squared minus 20x. How many people got that? Hands up. Awesome. What do you have to be so careful about with number 4 now? We've changed it. What's changed? What has changed with number 4 that you have to be super careful about? Yeah, the sign. This minus sign. Oh, that's so mean. Okay, you got to really be careful with that when you're multiplying. Okay, multiply in. Go for it. Collect like terms. Okay, so here we have 10x squared plus 20x minus 15x squared minus 3x. Altogether, we should have negative 5x squared plus 17x. Is that correct? Good. Hands up if you got that. Perfect. Okay. So now we're into a little more challenging ones. We have more than one letter. Okay. So if they're a different letter like this, you multiply to get negative 12, and then you write it x, y alphabetically. Okay. Letters side by side imply a multiplication. But for the next one, there's y's. So your numbers go to plus 6, and your y's become y squared. Okay? Okay, try this one. Go for it. Yep, 18. Okay, combine like terms. Am I correct? In green? Awesome. Okay, try 6 now. Okay, so we got 6c5 minus 15c cubed d minus 8c4 minus 12c cubed d. Okay, so the 6c5 can't change. This can go to negative 27c cubed d minus 8c4. Probably a better order would be 6c5 minus 8c4 minus 27c cubed d. The only terms you can combine are these two, because the exponents and letters must be the same. Okay? Any questions with that? Okay. So what we're going to do now is we're going to do a different multiplication. Up top when we multiplied, it was a one-term multiplication. But now we have 2 terms. So we need to draw this. Without drawing it, it's hard to see what's going on. Okay. So real quickly, we're going to draw x plus 1 over here. And x plus 4 over here. Okay. Draw the inside then. Okay. So tell me what it equals after you've done your drawing. What's the product? Who's got it? Jordan? Awesome. Okay. So we have 2 terms being multiplied, and we end up with a trinomial, 3 terms. Okay, so we have a binomial times a binomial equals a trinomial. Okay. Any questions? All right. So that's going to happen all the time. Now, there will be some special cases. So what I want you to do, though, is do a quick little check. There's kind of a quick little cheat way to check this, is you can replace x with 10. Okay? So if we replace x with 10, x squared plus 5x plus 4, this would be 10 squared plus 5 times 10 plus 4. So 100 plus 50 plus 4 would be 154. Guess what, folks? You can tell that because it's 1, 5, 4. Those are the digits, 1, 5, 4, because that's the coefficient. Okay? It is. So what we do here, okay, if we have x plus 1, x plus 4, here we would have 10 plus 1, right? So we're just replacing it. And this would be 11 times 14. Now that's easy to do because the 11 breaks down to 10 times 14 and 1 times 14. So 140 and 14, add them up, 154. So these two are equal. Okay, so the question part is equal to our answer part. Okay, just a little trick to show you. That's all. Okay? It's not imperative. Some people like it and use it all the time to check. Some don't. Okay. You guys okay with that? It's pretty crazy stuff there, but I want to show you. All right. Good. So you can always check by using x equals 10. Helps you out. All right. Draw this one now. X minus 1. Whoops. X minus 1 times x plus 3. Now you got to watch out for shading. Okay, so after you've drawn the shape, you want to shade in this -1 multiplication. So what's your final answer? X squared. Now what? Plus 2x, but I don't get it. I have 3 here. Here's a 3x. Oh, this is a -x. So you have 0 pairs forming. So you got to be super careful and cross off 0 pairs first. Now you can see there's a plus 2x. Okay. And the last part would be -3. Now, when you're substituting the expansion by 10, this would be 100. The second part would be 20, and the last one's -3. So it's 120 minus 3, 117. Right? So this is 100, this is 20, and that's -3. When you multiply it by 10, right? So 10 squared plus 2 times 10 is 20, minus 3. So let's check. X minus 1, x plus 3. So this would be 10 minus 1, 10 plus 3, 9 times 13. Well, what's 10 times 13? 130. So then you can take away 13, 117. Okay, so this equals 117. So they're equal. All right. Questions? How are you guys doing with this stuff? I'm not too concerned about the checking the expansion. That might be like one question on a test, like the top question. Okay, it's not something we normally do. Okay, multiplication statement. X minus 1 times x plus 3 equals x squared plus 2x minus 3. Okay. Okay, so now we're going against some harder ones. Draw it. Okay, so I have to double check my shading. This should be shaded. This one should be shaded. These ones should be shaded. But what about my 1 tiles? Absolutely not, because this would be negative times negative. So my final answer would be 4x squared minus 8x plus 3. Is that what you guys got? Awesome. Okay, now you could do your expansion too, if you wanted. That'd be 400 minus 80 plus 3. So it'd be 320 plus 3 would be 323. Okay. So then I go 2 times 10 minus 1. 2 times 10 minus 3. And you probably do more of this stuff in your head, right? 19 minus 1. Sorry, 19. Times 17. Now you could even just quickly check on your calculator. 19 times 17. Yep, 323. We're right. Okay? So 323. So you're just checking that what you expanded is correct. Okay? Am I going to quiz that? Most likely not. What I put on a test is like the hardest question.